Good day, everyone. I am Eduardo Gallinaro Jr., a fourth-year BS Mechanical Engineering student of Bohol Island State University main campus. So now I will present to you my laboratory report 4 entitled Design of a Single House Air Conditioning System. So this is my introduction. Air conditioning has now become a need. It's a refrigeration-based appliance found in nearly every home and business in the developed world. An air conditioner keeps you, your family, and your coworkers cool. It is also aids in the preservation of health, particularly for those who live in areas with harsh weather. Air conditioning design and installation, on the other hand, are not simple tasks. To apply it efficiently, you'll require professional expertise and experience, as well as consideration of a few essential elements. So, kay man ta na nga kaning aircon is not new for us kay makita mo jud na ani ka sa atong palibot kay air conditioning is very useful for us, especially yung maka-experience tagka-init sa atong adlaw. So in order for us to be comfortable, magpa-aircon ta para maka-feel tag kabugnaw. So primary purpose for this is to create a room climate comfortable for humans. So it is not just only for humans but also for to cool the temperature of electronic devices para ma-avoid sa kasunog or damage sa electric devices tungod sa kainit. So muna siya. And then let's proceed to the components of an air conditioner. So these are the following components of air conditioner. First one, compressor. The compressor is the engine of the system as it works with a fluid that easily transforms the gas into a liquid. So, ang kaning compressor, ang primary function ani niya is to convert low pressure gas into high pressure gas which has a high temperature. So, from low to high pressure gas. Manay primary function sa compressor. Then next, condenser coil. The condenser coil contains a fan that cools the high pressure gas and converts into a liquid. So from high pressure gas, convert into a liquid. So gikan sa kainit padong sa pabugnaw. So muna siya. Then next would be thermostat. The thermostat maintains the temperature of an air conditioning system as it regulates the heat energy inside and outside. So, depende ani nga design ang thermostat, it's either iset nimo manually or automatically. So, and then let's proceed to evaporator. Evaporators are air conditioning components found inside the house near the furnace. It is connected to the condenser and extreme thin pipe. So, nagka-connect na siya sa gikan sa condenser to evaporator. So, it's a cycle. So, from high pressure gas transform into a low pressure liquid for an air conditioner. So, from high pressure gas into a low pressure nga liquid. And then, last one, air handler and blowing unit. So these components of this air conditioner work together to pull air to evaporator and calculate cool air around the room. So um, ang passage ni siyang airflow sa room is ang mag-facilitates ani niya is ang duct system. Siya. And then let's proceed to the complete diagram of an air conditioning system. So, as you can see in this figure, this is the complete diagram of an air conditioning system. Makita na to nga na evaporator, reversing valves, solar collector, condenser, bypass valve, compressed vapor, compressor, vapor refrigerant, bypass valve, liquid refrigerant. So, mo siya ang complete diagram of an air conditioning system. So now let's proceed to 2.0 methodology. So in this section, it shows the methodology in designing of an air conditioning system suitable for a single house. So 2.1, this is the proposed type of an air conditioning system. So in this setup, central air conditioning type of system will be used. So as you can see in this figure, this is the proposed type of an air conditioning system, which is a central air condition type. Why? Because kani siya ang gipili because it is most common type of a cooling system, and it is preferably used in larger homes because of its efficient cooling. And then the conditioning system circulates cool air through supply and returns into the ducts. And in this type of system, there is an advantages and disadvantages. So let's proceed to the advantages. First one, it cools all the rooms connected to ducts at once, thus creating a cooler and regulated environment around the house in minimum time. Second one, since cool air is circulated in all rooms, humidity is reduced around the house, making the overall environment more comfortable. So let's proceed to the disadvantages of a central air conditioning systems. It consumes a lot of energy, resulting in higher energy bills. Such units may lose efficiency and effectiveness in case a problem arises in the ducts. Some find outdoor unit to be unattractive, but you can always creative hide your air conditioning unit in your backyard. So that is the advantages and disadvantages of this setup. So now let's proceed to the specification of a proposed central air conditioning system. So as you can see in this table, this is the specification of the proposed central air conditioning. So this is the model. This is the model name, Goodman GSX 130481 central air conditioning system. So na sa table iyang mga specifications. So kani siya akong gipili because it is one of the top preferred models for the people who desires quieter operation and superior comfort and environmentally friendly performance. So unlike sa ubang mga air condition karon nga gipanggamit is ang kasagaran nga gigamit is R22 nga refrigerant, but in this case ang gigamit ani niya is R410A because it is a liquid coolant, does not have chlorine, therefore ensuring that it does not cause any damage to human health as well as to the environment. So mo na naka nindot ani nga setup. So now let's proceed to the plant layout of air conditioning into the house. So mo siya, as you can see in the figure, this is the complete plant layout of air conditioning into the house. And then let's proceed to the parameters. So these are the following parameters that need to be measured in designing a single house air conditioning system. So first one, atmospheric air. So these are the outdoor and the indoor conditions temperature that are being measured with the use of digital thermometer. Second, humidity. These are the humidity of both outdoor and indoor conditions with the use of psychrometric charge. And then sensible heat gain sa house. This is one of the components of a cooling load when there is a direct addition heat to enclosed space. Again in the sensible heat is said to occur. Then last one, latent heat gain sa house, sa tibok house. So it is also one of the components of a cooling load. And when there is an addition of water vapor into the air of enclosed space, again in the latent heat is said to occur. So now let's proceed to the instruments. So the instruments being used to measure the data. So the first one is the digital thermometer. So it is used to measure atmospheric air temperature. So as you can see in the figure, so this is the digital thermometer that atong gigamit for measuring the atmospheric air. Then next would be the psychrometric charge. So it is used to measure the humidity of the following air atmospheric conditions. So man siya itong pagpangita sa atong humidity ratio. So now let's proceed to the problem and condition. So mo ni siya ang problem and condition sa atong house. So nakita na to ang pilang area niya, pila ang area sa walls, windows, and other various sources. And the estimation of sensible heat gain. So one door is 2.5 by 3, and the area of one window 2.5 by 1.5 is 3 meters squared. So from the study of Bharati P. et al. 2017, the total room sensible heat is 107 kilowatt and the total room latent heat is 71.6 kilowatt. So now let's proceed to the last part, the results and discussion. So by the use of the digital thermometer and the psychrometric charge, the researcher me obtained these values. So this is the outdoor and the indoor condition. From outdoor condition, as atmospheric air, we got 43 degrees Celsius dry bulb temperature, and the humidity ratio 0.0277 kilogram per kilogram of dry air. Then indoor conditions, atmospheric air 25 degrees Celsius dry bulb temperature, and humidity ratio 0.01 kilogram per kilogram of dry air. So, and number of persons, 20 persons. So now let's proceed to the table, which various sensible heat gain sources. So as you can see in this table, this is the sensible heat gain from the various sources. So from the calculations, we got the total room sensible and latent heat. So this is the atong nakuha nga kuan total room sensible heat o total room latent heat. So the total room sensible heat is 90.37 kilowatt and the total room latent heat is 44.32 kilowatt. So in this experimental design, it shows that there is a cooling improvement to the house because sensible and latent heat is decreasing compared to the study of Bharati P. et al., which 107 kilowatt and 71.6 kilowatt respectively. So it is cooler than the other study. So that's all, and thank you. I hope that I can give you some knowledge about my design. Thank you.